Hello all. Today we are going to start with the next topic, that is differentiation and derivatives. So the concept of derivative is extremely used in economics and managerial decision making, especially in the problems of optimization. But when we consider derivative in maths, it refers to instantaneous rate of change of quantity with respect to the change in other variable. Okay, means change in one variable with respect to change in other variable, right? So like we can take an example of a car. Suppose a car moves um, from a point A to B. Okay, let's see, we make this a line. This is a distance A to B. In between we have a C point also, and it take t seconds to complete the journey from A to B. Okay, and let's suppose that x will be the distance covered and t will be time taken. Okay, so now but the question here is how long will it take to move from point A to C? Okay, and how long will it cover in t minus 1 seconds? How much distance it cover in t minus 1 seconds? So these kinds of answer can be solved with the help of a formula. Like suppose we have to calculate velocity, so in that case it is represented by v. It is dx divided by dt, right? Now means dx is, x here is distance covered and t here is time taken. Okay, so this will give you the distance covered per unit time so that we can analyze any distance covered in any moment of time. Okay, and this dx by dt can also be known as differentiation. Okay, and the process of finding derivative is known as differentiation. Okay, so a derivative, what does a derivative basically do? It allows us to find out the rate of change in y. Change in y can be represented by this triangular sign or delta with respect to x. Okay, change of rate of change of y with respect to x, where y is taken as dependent variable and x is taken as independent variable. Okay, fine. So now we can take one more example to clarify this concept. Let us take the example of income and buying pattern. So income and buying pattern. Now, where income is taken as independent variable and buying pattern is taken as dependent variable. So the concept of differentiation will help us to measure the change in buying pattern, if there is change in income. Okay, so if there is change in income. Now if we assume buying pattern as y and income as x, so we can say that we have to find out the change in the change in y with respect to change in x. Okay, and this is the concept of differentiation, and how we will represent it in differentiation, as it is represented as dy by dx. Okay, so change in y can also be represented as dy and change in x is also represented as dx. Fine, this is not the denominator, this I have just explained you. So we can write it in the form of y is equals to function of x. Clear? Now, before proceeding further, let me explain you the concept of slope, because that is very much important if we have to understand the concept of differentiation or derivative. So what is slope? Slope is nothing. Slope is just a change in dependent variable due to change in independent variable. So let me explain the concept of this slope with the help of a graph. Okay. So let's make a graph. So we have two x's on the graph. On one side, I will take x variable, and on other side, I will take y variable. And let's see, there is some relationship between the two. So at this point of y, we have this much value of x. Okay. Let's say this is point P. Now, if I have to move toward point Q, let's say this is point Q, right? So we can say that this much increase in one variable will lead to this much increase in other variable. So you can see that change in x will lead to this much change in y. Okay. So basically, in explaining the slope, it is clearly said that, as I have already told you, that I will take one variable as independent and other as dependent, where y is taken as dependent variable and x is taken as independent variable. So here we say that whenever we have to calculate the slope, in this case, change in independent variable, that is delta x, right? It gets smaller and approaches toward zero. Zero toward means this line. Okay. So we can say delta y upon delta x became better approximation of the slope. Slope of the function by slope of the function where f is equals to, sorry, you can say here where y is equals to function of x. Okay. So this way we will able to calculate the slope at a particular point. So thus if delta x is extremely small, so delta y by delta x, this is called the derivative of the function with respect to x. Okay. So the derivative can clearly precise as d delta y by delta x, or I can write it as dy by dx. And ultimately we say that more precisely the first derivative of function is defined as limit to ratio delta y by delta x as delta x approaches toward 0, approaches to 0. Okay, 0 means toward this side. Now let me explain this with the help of formulas. So means whenever we have to calculate that, we have to see that how differentiation is calculated, or we can write it as what is the derivative in particular function. Okay, in particular function. Fine. So first of all, what we will do, derivative of a constant function. Now see this, what is constant here? Whenever a constant function is expressed as y is equals to function of x is equals to a, where a is considered as constant. Now what does this implies? It implies that y does not varies as x varies. With the change in x, there is no change in y. Why? Because a is constant. So we can write here as dy divided by dx is equals to 0. Let me explain this concept with the help of another graph. Let us take this. So let us assume that x is equals to 3, or A is equals to 3. We can write it in the both way. So we have to find out y. Y is equals to function of x is equals to a, and where a is equals to 3. Okay. This is not sign of divide. This is or. Okay. A is equals to 3. So in that case, 1, 2, and 3. So this is my value of x. This is 3, right? It will remain 3. It is remain 3. Okay, so with the increase in the value of x, the value of y will remain same, means no change in value of y, no change in value of y. So this clearly shows that derivative here is equals to 0. Why 0? Because there is no change in the value of y with the change in the value of x. Clear? Let's proceed toward next method, that is derivative of a function using first principle. Okay, so first principle is what? It is also known as ab initio or delta method. Ab initio or delta method. Okay, so what is this? If you remember, we have done slope in which we have written that delta y divided by delta x, or if I make a diagram again, if I make this graph again, here we have x, here we have y, this way, and this is our first point, and this is our new point. Okay, so you can see here that we have already done y is equals to function of x. Clear? Now, if we use the first principle, right, in that what we have to do, we have to first of all write down this the value of slope. Slope is this. Okay. So now in the diagram, that you see this is my first value of x, this is my initial y, and these are my increments value. Okay, so next what we have to see, you can see here that x changes from x to x plus delta x, and y changes from y to delta y. Okay, clear? So we can write here as two equations that y is equals to function of x. This is my first equation, and if we add increment to both side, we will get y plus delta y is function of x plus delta x. I'll take it as second equation. Now what I will do, I will subtract first equation from second. So what I will get, I will get y plus delta y minus y is equals to function of x plus delta x minus function of x. Okay, so in this case it will cancel. I will get delta y is equals to f x plus delta x minus function of x. Now what we will do, we will divide both sides by delta x. What I will get, I will get delta y by delta x is equals to x plus delta x minus function of x fx divided by delta x. Here I have this is delta y by delta x. Okay, here I will get delta x. Now adding limits, adding, or you can say taking limits. Okay, taking limits, that is delta x approaches toward 0. So what I will get? I will get delta y divide by delta x, where delta x approaches towards 0. So I will get dy by dx is equals to function of x plus delta x minus function of x divided by delta x. So let's take y is equals to function of x square. Okay. So what we have to do first, we have to add increments here. Add increments. So that I will do y plus delta y is equals to f plus x plus delta x whole square. Okay. So the next step is we have to, so what we will do, we will add y plus delta y is equals to f into f plus delta x whole square. Okay. So what we will do, we will open this a x plus delta x whole square by applying the formula a plus b whole square. So y plus delta y is equals to x square plus delta x square plus 2 x into delta x. Okay, so this is my first equation, this is my second equation. Now simplify, we have to subtract, that is 2 minus 1, second equation minus first equation. What I will get, y plus delta y minus y is equals to f into x square plus delta x square plus 2x into delta x. So let's take y is equals to x square. Okay. So whenever we have to take y is equals to x square, what next step we will do? We will add increments to both sides. This is y plus delta x is equals to x plus delta x whole square. Okay. Now we will open this by applying the formula a plus b whole square. What I will get, y plus delta y is equals to x square plus delta x whole square plus 2 into x into delta x. Now this is my equation 1 and this is my second equation. What I will do, I will second minus 1 means first equation is to be subtracted from the second one. So y plus delta y minus y is equals to x square plus delta x square plus 2 into x into delta x minus x square. So what I will get? I will get delta y is equals to delta x square plus 2 into x into delta x. Okay. Now divide both sides by delta x. Divide both sides by delta x. What I will get? Delta y divided by delta x is equals to delta x square plus 2 into x into delta x divided by delta x. So the next step, what we will do, we will take delta x common from the right hand side. So what I will get? I will get delta x plus 2x divided by delta x. Okay. And ultimately the net value will be delta x plus 2x. Okay. Now next step is applying limits, means delta x is approaches toward 0 as delta x
approaches towards 0 by applying the limits, what I will get? Delta y by delta x limit is equals to dy by dx. I will get dx, okay, 2x, sorry, because delta x is approaches towards 0, so most obviously the value will become 0. So we can write here that the derivative of x square is 2x. So this is the way through which we will able to get the derivative with the help of first principle. I hope the concept is clear. Thank you.